Okay, in this problem we want to find the points of intersections of the graphs of these two equations. So here we have a parabola and a line. So in terms of what the solutions should look like, well, how many points of intersection are there going to be? Well, just by looking at the equations, we don't know exactly, but we can narrow it down to three cases. Well, we could have a parabola here and a line here, so there could be no solutions. We could have a parabola here and a line here, so we would have two solutions. Or the third option is we could have a parabola here, and we could have a line that's sort of tangent to that parabola. We'll define the word tangent actually later on in the semester, but there's one solution. So when we have a parabola and a line, it's possible to have 0, 1, or 2 solutions. Now let's just work through the problem. We don't have to know exactly how many solutions we're looking for when we start. Okay, let's get rid of this to free up some room, because I want to split the whiteboard in half. Because I want to do this problem two different ways. There's a number of ways we could do this, but I think the two most straightforward ways would be using substitution or elimination. Now, with the substitution method, we could solve one equation for one of the variables and substitute that into the other equation. So what I'm going to do is take the second equation, which is negative 2x plus y is equal to 14, and rewrite that as y equals 14 plus 2x. So basically just add 2x to both sides to get y by itself. And so equation number 2 becomes this. Okay, so now we go to equation number 1, which is x squared plus y equals 17. Well, we just solved for y, so in place of y we could plug in a 14 plus 2x. Let's use green for that. So this 14 plus 2x could go in for that y. So we'll have x squared plus 14 plus 2x equals 17. So now we have a single quadratic equation with one variable. We can, there's many different ways we could solve this problem. Substitution first, and then at this point we could use the quadratic formula. We could try to factor, and we could use completing the square. I'm going to try to see if this thing factors. So let's subtract 17 from both sides. And we'll use the zero factor theorem, see if this factors. So we'll have x squared plus 2x minus 3 equals 0. And yes, it looks like this does factor to an x plus 3 and an x minus 1. Which tells us that x could either be equal to negative 3, or x could be equal to positive 1. So that means there's two solutions, and the x coordinates of the two solutions are now known. So our solutions to the problem are the points negative 3 comma something and 1 comma something. Okay, so let's go back up here, and I'm going to revisit this guy, the y equals 14 plus 2x. Okay, well, if y, let's use blue because it was blue up there, y equals 14 plus 2x, well then, if x is a negative 3, then we get y equals 14 plus 2 times negative 3, or 14 minus 6, which is 8. Okay, so when x is -3, y is equal to 8. And when x is equal to 1, y equals 14 plus 2 times 1, which is 14 plus 2, which is 16. Okay, so those are our two solutions, our 2 points of intersection. We could zoom in a little bit here to catch everything. Okay, so those are our two solutions. Now, like I said, we could have used the elimination method, which is just an alternate method for solving systems of equations. So we have x squared plus y equals 17. We have a -2x plus y equals 14. And if we subtract the first equation, the entire first equation minus the entire second equation, so if we do this, well, we have a y minus a y, so they cancel. And on the left-hand side of the equal sign, what are we left with here? We have an x squared. We have a minus 2x, so that's a plus 2x. And we have equal 17 minus 14 equals 3. And if we now subtract 3 from both sides of this equation, we have x squared plus 2x minus 3 equals 0. And I'm going to stop here. There's obviously no need to keep going because we have the exact same quadratic equation, so we would solve it. We would get -3 and 1 and plug those numbers in and get the same points. Okay, I hope this was helpful.